So recording has started. Now we start. एक दो तीन चार पाँच छः। हाँ तो यहाँ पे 15% तो फैकल्टी है, राइट. सो वी वर डूइंग दिस एंड so the purpose of this example was, if you just go from left to right, you don't gather enough information always. So going left to right is okay, right? But there are examples where just going from left to right will not be enough. So you will need information from both the directions. So if this were a bidirectional RNN, a unidirectional RNN in this direction won't be able to differentiate that this steady does not belong to named entity, whereas this does. But if you have a bidirectional RNN, right, then it will be able to do so. So nothing special. What we will do here is we will simply make this particular RNN bidirectional. Now, how will you make it? So, let me just use let's say this is my RNN. This is my X1. And this, of course, I am receiving A0, but A0 is a vector of zeros in this case. Now here what do I have? Here I have WAX, here I have WAA, and here I have WYA. Okay. Now what will happen? So there will be a next unit of this. So this is A1, and again you have X2, then this guy was Y1 hat, and this guy will be Y2 hat, and so on, right. This will be WYA again, and then you will have A2. So I have it here, X3 again, this guy will be WYA, Y hat 3, this will be A3, and so on. Okay. Have I drawn an RNN the way we were doing yesterday? I have drawn it in a different manner, but is it complete? Right? Okay. So now this is unidirectional. Yesterday we had this particular arrow, these two arrows straight, and this was straight going into this. So I have just changed the angles. Now let me take another element. So this one here, it takes X1 as input, okay, it gives it adds to y1, it adds to y1, okay, I mean it contributes to y hat 1, and similarly you will have here, this takes input x2, contributes to y hat 2, similarly you have it here, this takes input x3 and contributes to y hat 3. What is left? So this red part are, so what is white part? In which direction? Forward direction. Okay. Now you also need an exact same RNN in backward direction. So this guy must be receiving from the later one, but then this guy is going to and so on. Is it complete? Seems so. Okay. Now these guys are for the these are parameters for the forward direction. Okay. How do I change them? I mean, sorry. So these are my parameters for the forward direction. Let's say I have WAX tilde for backward direction, I will have WYA tilde for here, and then I have WAA tilde here, and so on. So you will have just roughly double the parameters. Okay. How will you compute y1 hat in this case now? So let's say you have, so what were the things we had here? We had AT, so we had AT. Now we will have, so what were the equations? Quickly tell me. AT was, AT was basically activation of, so we were using 10H fine, but what next? WAX XT plus WAA AT minus 1 plus BA, and you also had y hat t. I will write y hat t later, but can you help me write A tilde t, where tilde I am denoting tilde for the reverse direction. Okay. What will that be? So AT will be 10H, or maybe I can write this whole thing in red. No, board पे जितना white चले उतना अच्छा. So 10H, right? 10H of WAX XT plus WAA AT plus BA tilde. What should it be? WAX tilde. Then does it depend on AT? I mean XT? AT depends on XT, right? So if you see here, whichever direction it is, forward or reverse, at tth timestamp depends on xt. Right. So Tth timestamps depends on Xt. AA, what will happen here? Tilde, what else? At plus 1 and B tilde, that's it. Now you have got these things, how will you write y hat t? How will you write y hat t now? Whatever you take, sigmoid or you take softmax, depending on what you are doing, whatever it is. I am interested in what will come inside. So you had W y a at plus by. Okay. Now you can do whatever, either you just keep this, in fact you can't really keep that. So what will happen? You concatenate. So one of the ways is you just, so your new AT that you will use here, right? This may be written as, you know, AT this was AT A tilde t. You concatenate, so if this was 100, this was 100, the real AT will become 200, and hence the parameters here will just double. So you can write the whole equation like we were writing before, plus W tilde ya plus by tilde. Of course you will have A tilde t here. Any questions here? I have not done anything. I have not done anything. If this looks complicated, this equation is AT for forward RNN. This equation is exactly same, just that you reverse. So this becomes A tilde t. This is your forward direction and this is your backward direction. Okay, and then y hat t questions then. How many of you are lost? How many of you are lost? एक बार raise your hands. How many of you are following this? Okay. So where is the problem? First two equations fine. See, first this equation is repeated here. AT for forward direction takes input from AT minus 1, but xt remains the same in both. For backward direction you will receive input from t plus 1. So this is what it is, and why I am using tilde, because these are different parameters. Okay. Finally, how will you compute y hat? So here if you see, you were receiving input only from the forward direction. Now you are receiving from both. So just take both these inputs, that's it. So which part is not clear? Tell me, and I'll repeat that. Which one? Or maybe just have a look at this and you will be able to figure out. So what is this part? Coming from the forward direction. This part is coming from the backward direction. You can do a few other things if you want to, but this is one of the things that we can do. So this is bidirectional RNN and done. Okay, nothing special here. Now I was supposed to do last line. This is simply, you can write this new 80. You can write this new 80 as a concatenation of these two 80s. So this was 100 cross 1, this will be 100 cross 1, you can just concatenate them and this thing will become 2 into 100 cross 1. Yes, so this is not that now anymore. So thank you for this. This is another way of doing the same thing. Okay. Questions here? Just that number of parameters are doubled down.
सर अगर 80 को अनदर वे की तरह लेते हैं तो डब्ल्यू बाई ए और डब्ल्यू बाई टिल्डा मतलब डब्ल्यू बाई टिल्डा ये दोनों डायरेक्टली एज इट इज आएंगे या वो भी कॉन्कैटिनेट होगा?
See, if you concatenate this one, so I did not really want to go into this, but they are, see, this is just another way, else they are the same thing. So you have this 80, so this is my 80, okay. Now this is a tilde t. So what is the dimension of this particular vector? 2 times 80, and for us 80 has been 100, so this guy becomes 200 cross 1. Now your WYA originally was WYA 1 cross 100. See, this WYA must be 1 cross 100 if I am doing a logistic regression here. If I am doing a softmax here, then number of classes cross 100. Okay. So this was 1 cross 100. Now this is 200. Will 1 cross 100 be sufficient here? No. So you will need a matrix. So you will need a matrix of size 1 cross 200, which is same as like writing this separately, because you will have 100 terms again. Okay. Deep learning is all about getting the dimensions of your matrices right. If you are doing that, most likely things are fine. Okay. All the debugging, I mean all the bugs in your code that you will get, maybe more than 60 to 70, in fact more than 70-75% of them will be because of dimension mismatch. Okay, so we are done with bi-directional RNNs. There was nothing special with them. As I have said many times, deep learning is just a hack, right? So wherever you can do some kind of jugaad, just do that. Now, so now I have a question in front of you. I have language model. What do large language models do? They are large language models, okay, and we are going to just talk about language models. So we are dropping this word large right now. So language modeling is an old problem, and what it does is you have to tell me, it can be posed in many different ways. One is given some n words, you have to predict the next word. Okay. So given context of n words, you can't have infinite context. So you will have some finite n words, just give me the next word. What else is it? It can be also said as, probability of a given sentence. What is the probability of a given sentence? They are one and the same ways of looking at things. How do you formally define this? So let's say if the question is what will come at the question mark? After looking at the clock, the proctor asked the students to open their exam, maybe. Okay. Like when you go to JEE exam, right, you are not allowed to open the exam book until instructed to do so. Okay. So something similar. Is this fine? Now somebody tells you that the context is only 4 words. So this is your context. Will your answer change? The students to open their lunch box. Okay. What else? Books. So does context matter? Of course, in language context is everything. Okay. So if I give you just context of 5, does this exam go away? Right? There are other words that are better candidates in place of this exam, but if I give you full context, then the probability of exam is much more than book or lunch box or whatever else you might have said. Okay. So the problem of language modeling is to decide the next word in the sequence. Okay. And how do we define this formally? How will we solve it? Tell me. We are not going to use deep learning to start with. How do we do it? Yes. No deep learning, simple statistical thing. Tell me, how will we solve this problem? So how can I write this? The probability of second word given first word. So what will be the probability of a sequence? What will be the probability of a sequence? Right? The probability of first word multiplied with the probability of, what is this thing? Second word given first word. What is the probability of third word given that first two words were this? I mean, maybe W1 comma W2 dot probability of W4 given W1, W2, W3 and so on. What is this? This is the probability of sequence W1, W2. How do I formally write? I mean, this is what it is. What will be the last term? What will be the last term? Probability of Wn given W1 all the way to Wn minus 1. Is this simple enough? Right. So this is what it is. Now how do I write in just, how do I make this formula compact? This is equal to what? So probability of Wi given W1 to Wi minus 1 yes. What? Pi, very good. I goes from 1 to n and that's it. Okay. Where is this problem helpful? Where is language modeling helpful? Everywhere. Wherever you see language, everywhere, because most likely in language you would be generating things. So for example, how will this be helpful in translation? If you are converting a source language text to a target language text, you still need to generate, right? Where else? Speech recognition. So somebody has said, please give me a glass of beer. Which beer? BEER or BEAR? How would the system know? Somehow it should know that in language, since this context has glass and everything, you can't fit a bear into a glass. It must be BEER. Okay? And so on. So, for example, let me take example from Andrewing slides now. So he says, the apple and the so if You have a speech recognition system. अच्छा इधर देखो इधर देखो. So if you have a speech recognition system and somebody said the apple and the pear salad, which one your what speech to text system, which of the two sentences it should go for? The second one. Why do you think so? So do they sound similar, both the sentences? Yes. So for speech they will most likely be the same, but in written English they are very much different. This in fact makes absolutely no sense. Okay. So it must be this. How would you make sure that this happens, or at least how would you increase the probability of this guy? See, how does language work when you deal with it statistically? So they say that, for example, so how does system decide? So let's say the probability of occurrence of this sentence is 3.2 into 10 to the power minus 13, and let's say the probability of this is 5.7 into 10 to the power minus 10. Which one has the higher probability? The second one. So the system should go for this one. Why the probabilities are so low? Why the probabilities are so low? Go back here. Go back here, the probability of first word. What will be the probability of the first word to be the, for example, 0.07? What will be the probability that apple will follow the? Much lesser than this 0.07 now. So if you go all the way until this fifth or sixth word, I think this is actually high, right? They might be even lesser. Yes? Yes, this is SMT. So this is not SMT, this is statistical language modeling. Okay? So those who are doing NLP should make sense of this. Now, so since today I am going to talk mostly about statistically, in fact probably not, because I am done with that. So how would you do this? How would you do this statistically? Deep learning bhul jao ek baar. I am just asking you, you have a huge corpus. So you have a huge corpus and now you are supposed to auto complete that. The students kya tha wo asked to open their whatever. Okay. So how will you write, how will you complete that fill in the blanks? So, or maybe you can take it here itself. Let's say the apple and the pear salad. So let's say I am supposed to predict this word. How will I do this? Can you give me a couple of more candidates here? The apple and the pear? Fruit? Juice. Okay. The apple and the pear juice. So these two candidates are good ones. So how do I do this? Simple math, no machine learning, no deep learning right now. Just do statistical analysis. So, and okay, you are given a huge corpus. Okay, you are given a huge corpus in English language. A lot of text is given to you. अब तो बताओ यार. and let's say your context is just one word. If your context is just one word, okay, and let's say peer appears 1000 times in your corpus. So let's say peer appears 1000 times. What would happen? You look for all the next words of peer. Okay, let's say 600 times we had juice. Let's say 200 times we had salad. And let's say what more? Let's say 100 times we had, give me one more thing. Juice, salad, what else? Huh? Tree, yes, thank you. And so on. And let's say 50 times you said seeds. So thank you so much. And so on. What is the probability? So now I am supposed to fill in something here. I have this information, right? What will you fill in? Always? Always? Will you always auto-complete this with juice? So you get a probability distribution. What is that? You will complete this with juice 60% of the times. That means probability is 0.6. 0.2 probability of salad, and so on. So you have a probability distribution. Can you go outside from this one? Let's say you have 28 such appearances. So these numbers will sum to 1000, okay, and you have 28 such words. So in this approach, can you fill it with some 29th new word? No, that is not in your knowledge, you can't fill it, okay. So that is one of the problems with this, but people were doing this until deep learning started taking over, okay. Now let's say you don't take context as 1, you take context as 2, what will happen? Tell me, will this 1000 decrease or increase? Can it increase? Can it increase? It certainly cannot increase, because if peer alone was 1000 times, appending there here will only shrink the appearances, this kind of appearances. नहीं समझ रहे हो बात को? See, peer alone was appearing 1000 times. Now you are saying the peer should appear. It can appear at most 1000 times. But do you agree that it won't occur 1000 times, right? So if I do it for the peer and I ask you what will be here, it occurs, let's say for example, let's say 100 times. Will you have a different probability distribution now? If I take my context to be this, then even lesser, and so on. What are the problem with these things? See, if I give you just one context, it is too little for me to decide what will be the next word. We have seen it here. Dekho. We have seen it in this example, this one. If I give you, so if I give you just there, right, you can fill it with so many different words, but they will all be vague. They will not make sense probably in this, the complete sentence. The moment I keep on increasing the context, what will happen? The probability that it occurs in your context, in your corpus will be lesser and lesser, right? And what is the probability that this exact sentence will appear in your corpus? Very low, if not zero, right? And will it start moving towards zero the moment you keep on increasing the context? Yes. Okay. More context helps me find definitively this word more correctly, accurately, but more context in the statistical sense also means less probability of finding the context. So we have two contradictory things here, and this thing does not work. I will not go into all the problems of this approach. I just wanted to tell you that if I increase the context, probably I have not seen that particular. So this is 1, 2, 3, 4, 5. This is 5 gram. If I take just this, if I take just 4 words, so the number of continuous words are called grams. If you have just 1 gram, what does it mean? Just one word, unigram. If I have 2 words like open there, to open, students to, the students, ask the, proctor ask, 2 continuous words, what are they? Bigram. 3 continuous words, trigram. Then 4 gram, 5 gram and so on. So as n increases in n gram, as n increases in n grams, statistically the probability of that n gram will keep on decreasing. So most likely I have not seen that phrase in my corpus, and it will be difficult for me to compute here because I will be simply saying I have not seen this before, and hence the probability of this is 0. Okay. These are the problems these traditional approaches to language modeling suffer from. हाँ, बिल्कुल हो जाएगा. So then you take log. So the workaround for wherever your numbers become too small or too big, you just take log. Okay. Right. Any questions here? So you know how to do this statistically? All you need to do is make such pairs and count in your corpus how many times do they occur. Just make a probability distribution and start completing. That's it. Here, yes. So let's say if you are sampling it, so 60% of the times you will complete it with juice, 20% of the times with salad, 10% of the times with tree, and 5% of the times with seeds, and so on. Maybe 30 for something else, and then finally let's say something appears just once, okay, and so on. So if context is just one, I will have more examples, but my answer will be vague. If I have more context, my answer will be better, but the probability of occurrence of this exact n gram is very low. So what gives me more information does not occur in my corpus, and what gives me information makes no sense in language. Okay, we'll start with the deep learning approach of it in the next class. मेरे को extra classes चाहिए होंगी because देखो RNNs निपट गया है, done, language modeling, and then we'll have to do LSTMs, we'll have to do vanishing gradients, मतलब पहले vanishing gradients, फिर LSTMs, and then attention mechanisms, and then transformer. 2 week बचे, मेरे को 3 चाहिए. एग्जाम के बाद किसी को लेन देना नहीं होता, ना मेरे को ना इनको।